So we are happy today to have with us Manos Koukoumidis and Matthew Persons, two of the co-founders of the Oumi startup, which is truly, as they will point out, open source platform for building and experimenting with large language models. Yeah, I know Manos more, so I'm gonna say just a few things about him, and he can then present himself. And Matthew, I know he was in Princeton and MIT. He had his PhD there. I know he has worked in Microsoft and lastly in Google, where he was, I think, leading the Gen AI Gemini project, if I'm not wrong, Manos. And also, I've seen that Matthew is also working the same team, the Gemini team. So, guys, thank you for being with us. And Manos, the floor is yours.
Yeah, thank you very much for having us here. Very excited to be presenting to the Democritos group. So yeah, for this, as you mentioned, until currently the CEO at Oumi, Oumi stands for Open Universal Machine Intelligence, as you can see. And until 9 months ago, I was at Google Cloud, supporting all the natural language services that we have at Google Cloud. And among others, as you mentioned, together with Matthew, we're bootstrapping the efforts for Palm. That was the model before Gemini, which then got rebranded as Gemini, where we continue to contribute in different ways. And yeah, before that, yeah, I spent some time, as you mentioned, Microsoft, Meta, for doing a PhD, mostly at Princeton, sometime at MIT. And yeah, Matthew.
Yeah, sure. So my name is Matthew, as was mentioned. I've worked with Manos for a good amount of time, last 4 years at Google, but I've been at Google for the last 6. At Google, I was the lead for the natural language team. As Manos mentioned, specifically the pieces I worked on was parameter efficient fine tuning and the API for serving for what was Palm, which became Bard, which became Gemini at Google. And before that, I also spent some time at Microsoft. And before that, I was over at Cornell University. So yeah, nice to meet you all.
Yeah, okay, with that said, we can get started. So today, Matthew and I will be discussing about why it is imperative, why it's critical that open source frontier AI succeeds, and the work that we're doing to make this happen, the work that we all need to do together to make this happen. As it currently stands, frontier AI has increasingly moved from open academic research to closed research and development that's happening behind the closed doors of a few well-resourced institutions, the few aspiring AI oligarchs. And this is very concerning because this is arguably the biggest opportunity that we have for the next wave of advancement of the sciences, the industry, and humanity overall. And this is now being increasingly controlled by a small set of this elite of tech science. And this is very concerning because it can lead to extreme concentration of power. You know, if it's only one or a handful of organizations that control access to this technology, it's going to be permeating everything. At the same time, you know, science and industry, they will be impeded. They can't function, they can advance based on the black box that OpenAI, Anthropic, or what we were building at Google, you know, provides. They can't function and operate and advance on a black box. At the same time, it's highly inefficient as a status quo. We talk with many academics, the US, Europe, and what they were telling us is that, you know what, we want to contribute the way we did in the past to the advancement of these frontier technologies. But actually, that's quote how they describe themselves. We're an untapped resource. We want to contribute, we want to help more. But if the models are closed, we can't really do that. And those organizations, they really don't want to make it easy or possible for us. At the same time, also, you may have seen about the concerns about the development, how, of course, there's limited transparency, you can't reproduce the results, there may not be enough investment in safety, you know, all these concerns about how frontier AI is being currently developed. But it's interesting to see, you know, how did we get here? So we got here because, first off, because of 2 practical challenges that comes with doing research in frontier AI. The first one is access to compute like the GPUs and TPUs or other accelerators. This is a post in X, in Twitter, by Jacob Forster, professor at Oxford, who is now a collaborator of ours, saying how he wished right before last Christmas that, you know, maybe somebody would grant his group access to more GPUs because they are very talent rich, but they don't have enough GPUs to do the research. Things are getting better, at least I can see in the US, little by little, you know, universities and academics, they're getting a couple dozen GPUs for their research groups, which arguably there's still quite a fair amount you can do. But yeah, things are getting better, but of course, this is still somewhat of a challenge. And then other one was that even for universities that had access to GPUs, or at least for the given number of GPUs they had access to, they said, you know what, it's still hard for us to do this type of research. We have to put together a lot of different pieces, from the training to the inference to the evaluation, to be able to do this type of research, just so that we can go and then improve the state of the art in just some very narrow area that we want. So there's a lot of things we need to put together first before we can do the actual research. Plus, even though we may have access, let's say, to a dozen GPUs, none of my students has managed to do distributed training because it's just too much to figure out. And this is, from Ruslan Salagodino from CMU, who is, he has one of the very strong research groups in the US. So these are the two practical challenges. And there's one more that it's not really a real challenge. It's more of a fictional challenge, a mindset. There's been people in the industry, Sam Altman especially, who has argued several times that it's hopeless. Actually, he said it's totally hopeless to compete with OpenAI. They go around bragging about how many GPUs they have and all the things that they have, pretty much making the community feel that, hey, you know what, there's, just kneel, to our feet, use our AI because we're the only ones who can build this. But then there was a wake-up call just a couple weeks back when DeepSeek launched. And people said, you know what, okay, actually, you may not need as many GPUs, as much compute to train. Of course, we all know that DeepSeek didn't just use 5.6 million to train the model. They used a lot more. But they still showed how you can do a lot of this research, even on lower-end GPUs. Yeah, maybe arguably they had access to some more efficient ones, but they published a lot of innovations that saw how they were able to work around it and make a lot of progress still. And of course, this brought an earthquake, at least in the US stock market, tech stocks plunging and everything. But I think, for me, what was perhaps the most concerning one is that it was just a wake-up call that, in the US and arguably also Europe were betting on the wrong strategy, especially in the US. I think in Europe, you could argue things are a little bit better, but especially in the US, we're betting double-digit to triple-digit billion on closed-source AI, and only a fraction of that goes to open models. And closed-source AI won't be the solution, whereas China seems to be investing much more on what's going to be the winning strategy. But actually, to go a little bit deeper into this, I think even what exactly China is doing right now, I don't think it's actually the real winning strategy. It's closer to what the US is investing on, but not really there. I strongly believe that the winning strategy, the future of AI, should and will be truly open. By this, what I mean is not just open model, which is, for example, what DeepSeek did or what Qwen does, where they train a model and they give you the weights, but you don't know how exactly it was built. But it will be truly open. It will be open data, open code, and of course, the model itself, which means, again, this goes by the OSI, the Open Source Initiative Standard, meaning you have access to the data, the code, the models, you can reproduce that type of research. But what we also say is that also open collaboration. So to elaborate on this, because it's something that's new, again, the first three are what also the Open Source Initiative suggests, is that there's been some frontier AI efforts in the past, from especially nonprofits like AI2, that release models like Olmo or Molmo that I'm sure some of you may have heard about. But then if you were to ask their own founders and say, their own leaders, how can is it easy for me to experiment with this? They will tell you, no, it's not really easy to experiment. Yeah, we release the code and the data and everything. Theoretically, you could reproduce it yourself, but it's hard. Plus, it only works with a specific model. So anyway, that's one of the things that, to really help frontier AI to advance, you should have all these three ingredients: open data, code, models, but also build in a way that is easy for everybody else to experiment on and build upon. And even better, in a way that more than one parties can work together on this. And I'll elaborate a little bit more also how we're making this happen. And first of all, to elaborate, why did I say that AI should be truly open? For one, this is, the best opportunity that we have to advance AI in the best possible way, so they can become the most flexible, the most powerful, the most trusted AI that we need, both for science and the industry. With all hands on deck, everybody contribute to make it better. And also, especially for safety, you may have heard also about concerns about how safe AI is and I'm not going to even talk about AI going rogue and these scenarios, right? You may stand on, have different views about this. But even as it currently stands, there's a lot of biases and safety issues that AI comes with. And the existing closed model providers, they're not investing enough. They're cutting corners because they want to one-up each other at the leaderboard and win on the scenarios that are more marketable, as opposed to investing enough on safety that, it's harder to extract the monetary value out of it. At the same time, why I think that, the right strategy, why AI will be truly open, is the following. And one thought experiment here is, the thing of what happened with Linux compared to Unix. When Unix first came out, built by Bell Labs, people said, you know what, it's like the ChatGPT of 2 years ago. It's the best operating system. Everybody will use this. Until Linux came out, it was not as good. But because it had the flexibility that people needed, they said, you know what, it may not be as good as the black box Unix, but it's flexible, open source. I can customize it to my needs. I can trust it more because, again, it's open source. But again, because open source, I can customize it, make it as good as Unix, if not better, specifically for my use case. And that's how more and more people started using Linux, to the point that Linux itself, the whole ecosystem became better. And, pretty much the whole internet, most mobile devices, even AI itself is now being built on top of Linux. The same thing is already happening for AI. We're exactly the same stage of, where things are when, with Linux and Unix. And the thing that I still say to people is that it will be happening in an even more profound way for AI, because where open source can really thrive is for technologies that are highly complex, where you need all hands on deck. You need many more people working together to make it better. As I also shared in my intro, with Matthew, we had studied the efforts for Palm, got to organize the efforts across how we iterated in the first few months across the quality. Then DeepMind followed the same model. And I can tell you this, preferably don't quote me, that there's not enough people at Google or even OpenAI, at DeepMind specifically, or even OpenAI, to advance its foundation models across all the different modalities and all the different use cases. And these are problems that can be very easily tackled in parallel by the community, where you have many more than just a couple thousand engineers and researchers. So that's why, even more than what happened with Linux and Unix or other complex technologies, PostgreSQL getting more market share than Oracle. That's why, especially for AI, open source has a very good standing chance. But if you ask and say, okay, but how would we do this? Is it easy or is it not? The quick comment here is that we have done this before. There's many huge efforts in the past where large communities work together to advance it. The Human Genome Project was thousands of researchers, more than 20 organizations. CERN, 10,000 scientists, hundreds of universities and labs, hundreds of countries, and not just people who were inside, the labs in Switzerland or France, but working with all the data across the world to advance the research. And the question I would ask here is, why, arguably, why would we want to do anything less for what is arguably our most important invention yet? Why would we want to do anything less for AI? And I really think that, countries and continents like the US and Europe should lead this. It shouldn't be state nations like China. It should be led by democratic nations. I think it's very important for many reasons that this happens. But to see, how can we really, solve this problem, starting from, how we got there, and, to see how we can go back and fix it. First of all, for this fictional mindset, fictional challenge, this mindset problem, I would say, just don't believe that. As we discussed, open source has a very good opportunity to thrive compared to closed source AI. For access to computes, it's getting better. I know, at least in the US, there's some programs. I've heard also of others in Europe that I'm very excited about. And as we will be discussing also later, at least for many of the universities we collaborate, we try to help with compute as much as we can. And then for the other one, for the platform that makes it easy to do this type of research, make it efficient for you to use the GPUs that you have so you don't waste them. That's why we build the Oumi research platform that makes it easy and also efficient to do this type of research, both in terms of human efficiency and also compute efficiency. And to talk a little bit more about how the research platform itself was built and works, I'll pass it off to Matthew.
Sounds good. Thanks, Mano. Let me steal the screen share from you here. All right, we're good, Mano. You can see my screen okay?
Yep.
Great. Okay, awesome. So hi, folks. I'm Matthew. I've already given my intro before, but as Mano mentioned, I'm going to talk about the Oumi research platform. Now, as Mano mentioned, specifically building foundation models and doing foundation model research is a hard problem. There's so many steps you have to take, from pre-training to fine-tuning, preference tuning, evaluation. I could go on. And for each of these steps, you have to have so many choices that you can make. You can choose the models you want, the data sets, and beyond that, you need to choose the tools that you need to use. It's an overwhelming number of choices to make, and this is where we decided to build the Oumi platform to make these choices simple and everything in one place for you. So out of the box, the Oumi research platform is fully open source. This means you can take it, modify it, and distribute it as you will under the Apache 2.0 license. But on top of that, we built it on top of PyTorch so that it can be, leverage the full rich ecosystem that is PyTorch, talk with things like Hugging Face, VLLM, SkyPilot, and is also optimized for any platform you want to run on, be it GPU, CPU, or NPU. And when we built this platform, we wanted to have two specific pillars in mind. The first is that we wanted to be community first. And what I mean by that is this should be usable by anyone and can be contributed back to, so we can share our learnings. We want to make sure that you can use Oumi at any scale. Maybe you want to do, local research, you're GPU poor or GPU rich, it shouldn't matter. You can run small jobs on your laptop, but we also want to be production grade, that everything you do is robust and can scale up from a job on a laptop or in a research lab up to production grade cloud or an HPC supercomputer. Now, let me talk a little bit about the actual launch of our platform, because to be honest, we were blown away with the response. We launched the Oumi platform about a month and a half ago at the very end of January. And within the first week, we had more than 5,000 stars on GitHub, and we're still growing. But honestly, for me, the thing that's been most impactful has been the actual response from the community. We have more than 500 active members in Discord. That number is still growing too from the time that we made this slide. And we've also been collaborating with more than 20 academic labs from some of the best universities across the world. And I believe there's probably some people in this call, but I've been going through and meeting with so many members of our community. I've met with hundreds of them over the last month, one-on-one, to discuss from countries all over the world. And what has been most inspiring for me is actually seeing how well this mission has landed and how eager these people are to work with us and push the boundary of what is, large language model research. So honestly, it's just been fantastic to see. Now, all that said, let me talk about actually what the platform is and how we designed our platform going forward. So at a high level, the Oumi platform was designed so you didn't have to deal with the headache I mentioned of choosing all these tools, all these models, all these data sets. We wanted everything to be in one place. So specifically, you can do anything you want for an end-to-end machine learning project, all within Oumi, be it training, evaluation, inference, parameter efficient fine-tuning, etc. It's all doable in Oumi, so you don't have to worry about juggling all the different packages you might use for each of these individual steps. And on top of that, we know that doing research needs to be something that you can customize. Oftentimes when you're doing research, maybe you want to use an existing model, an existing data set, but very often you need to do something customizable, maybe a custom loss, maybe you want to tweak different layers within your model, or actually customize, generate your own data sets, generate your own benchmarks. So we made sure that customization is a first party and a first-class citizen within Oumi. Also, as I mentioned before, some of the pillars for Oumi is making sure that this is community first and can be run anywhere. We want to be able to collaborate with folks across all scales of GPU richness, so you can run this on your laptop locally or scale all the way up to a supercomputer in the cloud. And the last part is that we want to make sure that everything we do is enterprise grade and research grade. And what we mean by that is you should be able to reproduce state-of-the-art recipes and share them with others. So everything in Oumi is based on a configuration. So you can get started. We have a big library of configs I'll talk about here in a minute. But you can have these state-of-the-art recipes that you can reproduce just in one line of code. Or as you train and maybe you do research using Oumi, we will actually produce these configurations for you so you can easily share the experiments you've run, and anyone anywhere can reproduce your results with one line of code. So that's the high level overview of the actual Oumi library. I'm going to run through the low level pieces. And specifically, I'm just going to run through this from the lens of someone who wants to do model training end to end and use the platform. And we'll talk through it together. So if you're going to do anything with machine learning, the first thing you need to do, of course, is actually pick a model. And as I mentioned before, Oumi has a wide selection of models you can pick from. We support all the latest and greatest models, from DeepSeek to Phi from Microsoft, Llama from Meta, Lava, Qwen. If you can think of it, it's likely supported within Oumi. And each of these configurations that we have, we can support all these models in multiple configurations. For example, like FSDP, LoRa training, QLoRa training, FFT, DPO. I'm not going to go through everything, but we have configs for all of these. And also we have configs for models ranging from, extremely small models like small LM, which is 135 million parameters, all the way up to Llama 405B, which many of you are probably familiar with. And we've tested training configs and inference configs and evaluation configs for all these models at scale to make sure they work for you. Now, we do have a demo down here that I can show you for how Oumi Train works, but we'll get into that in here in a few slides. So I'm going to skip over that for now. But now that you've selected a model using Oumi, the next thing that you can do is, of course, use a data set. In Oumi, we try to make data sets as easy as possible. We know that I think one of the biggest pain points when doing a machine learning workflow is actually massaging your data. Maybe you want to use multiple different data sets to all have different data set formats. Wrangling them is just a headache. So if you have any data sets that are in Hugging Face today, or you have your own local data set, you can actually go ahead and use those with Oumi. If it's in a standard format, we'll do everything we can to pre-process it to make sure that you can actually focus on what matters most when doing research, not writing thousands of lines of Python code just to convert data from one format to another, but actually thinking critically about what you're doing, mixing and matching these data sets, and actually doing the research that matters. So you can see here in this example, we create a dataset mixture. We're going to load the Lava dataset as well as some custom dataset we've made locally, and we can actually mix and match them and choose how they're actually integrated together. You can add different percentages and get the dataset recipe you need for your experimentation. So we have a model, we have a data set. The next thing you want to do likely is to actually train a model. So let's talk through it. In this case, maybe I have a scenario where I'm running locally on a machine that has one GPU. So I'm going to train a reasonably small model, maybe like an 8 billion parameter Llama model. What I can do is I can pick any of the latest, greatest models I want. Here we can pick a model that's just available via Hugging Face or locally. We'll pick the 8B Llama model, as I mentioned. And you can specify all of the different parameters you want to actually tune this model and tweak them as you see fit. We have a few examples on screen, like the learning rate, the batch size, etc. But any of these training parameters you're interested in, you can easily tweak. And what's also very cool under the scenes, or behind the scenes rather, is you can actually change the trainer type we're using. Perhaps you want to use GRPO, or you want to use the TRL SFT trainer, or Oumi's custom training loop because you have some certain plugins you want to test in a custom loop. Any of that's doable, and you can plug and play with just one line of code. Okay, now let's consider the case where maybe I want to train a larger model, but I can't quite do so. Well, we have support for parameter efficient fine-tuning. And parameter efficient fine-tuning we tried to make as simple as possible. For example, if you want to run LoRa training, you can enable LoRa training in just 1 or 2 lines of code here. You just enable LoRa, and then you just set the parameters you need, and you're good to go. Same with QLoRa. You can see here, we've turned on QLoRa, and we've set the number of QLoRa bits, and QLoRa training will work out of the box. Now, let's say, for example, you want to train in a scenario where you have multiple GPUs, but neither GPU can fully host your model. Well, you can easily use FSDP if you want to shard your model across these GPUs, and that's quite easy to do in Oumi as well. You can enable FSDP in one line and choose your sharding strategy, and you're good to go. Now, I want to also mention before we move on from training that Oumi has extensive telemetry because we've had to run Oumi at enterprise scale. We want to make sure that we log everything from bottlenecks to actually how our loss is progressing, anything like that. But in addition to the native telemetry and logging that Oumi has, we've also integrated with weights and biases, or WAN-B, and tensor boards. So you can get all the ML goodness and monitoring you want from those natively integrated into Oumi. Okay, so I've talked through training. We got a model, a data set, we've trained. The next piece you want to work on is evaluation. And evaluations in Oumi actually come in 3 pretty interesting flavors. The first thing we have in Oumi is, well, we have what's called evaluation backends. A backend is simply a framework for actually computing these evaluations. And currently we offer 3 with many more coming. The first of which we offer standard benchmarks through LM Harness. So if there's a benchmark out there, such as MMLU, HelloSwag, ARC, etc., you can already use these out of the box in Oumi. And then we also have generative evaluations, such as things like Alpaca Eval that you can use to generatively evaluate models. And then last but not least, we know, as we mentioned, that oftentimes in research, maybe you want to create a custom benchmark, or there's a very specific metric that's relevant to you that's not really in other packages. Well, Oumi supports custom evaluations. So you can write your own evaluation, generate your own benchmark or metric, and run that easily integrated with these other benchmarks from standard suites. Additionally, we also support an LLM as a judge, and this can be extremely useful if you want to create standardized benchmarks using these judges, or even assessing the performance of your data in certain scenarios. Okay, and the next piece I'll talk about is actually going to be something that you likely will use in evaluation, but you can use separately as well, and that's model inference. In Oumi, we support inference by using some of the latest and greatest inference engines. Many of you are probably familiar with them, but we support anything that you can probably think of, like Llama CPP, SGLang, VLM, etc. And these inference engines are very easy to use, and you can plug and play them, swap them out very simply. So for example, if I want to load a quantized version of a model, say the Llama 3.1 8 billion parameter GGUF, I can use a Llama CPP to do that. And in one line of code, I can load an inference engine where we can just go ahead and infer against our prompts. Similarly, I can load a model in SGLang or VLM, and we're good to go. The one thing I want to call out specifically is also our support for remote inference engines. And what we mean by that is actually being able to run inference against a remote API. So this is, for example, if you want to run inference against OpenAI, maybe some GPT model there, or Claude from Anthropic, or Gemini from Google, you can do that. But also, this works for the research scenario where maybe you have an SGLang or VLM server on maybe a local host, or maybe you have it in a small cluster somewhere on the cloud. So long as you know where that server is, you can just point your remote inference engine straight to that, and you can use robust inference from Oumi to actually query these self-hosted models as well. So the next point I want to talk about is actually for data synthesis, and specifically, this is our batch inference within Oumi. If you have an API that you know supports the OpenAI batch API format, you can easily use Oumi batch inference. And we've tested this at scale. You can easily run up to 50,000 prompts simultaneously to get your batch jobs done. And obviously, this is very useful if you want to do any kind of large-scale data synthesis, or even maybe you want to run evaluation and you have a very large benchmark that you need to run this on. So for data synthesis and for large-scale benchmarks, this is definitely something we suggest. So to recap, I want to talk about the actual starting points with Oumi. I mentioned before that everything in Oumi is configuration based. So we have hundreds of configs that are already available in Oumi today. And these range from training configurations to evaluation configurations to inference configurations for models of many different sizes. You'll see here that as an example, you can go ahead and load the Llama Vision model 11B. Maybe you want to do training here in this case using a text and vision multimodal model. Or for example, if you want to load ChatQA, it's extremely easy for you to do, and you can load that config immediately. And now while these configs are structured to reproduce, state-of-the-art results, they're also a springboard to doing your own research. So all of these configs are not fixed. When you load a configuration, it will load the parameters as they were done for that experiment, but you can easily change them for your own experiments and use that, as I mentioned, to springboard into new research. For example, I want to change the learning rate in a configuration. It's just a simple one-line change, and you're good to go. And then as you train, say maybe I've modified my configuration file, I've want to kick off training. When we're done training, we'll save this new configuration for you so you can share it and reproduce your results on any machine. Now, the last part I want to talk about in relation to our platform is actually how Oumi scales. I mentioned that we want to be community first and enterprise grade. So we've tested Oumi at all scales. Specifically, you can get started today using a Jupyter notebook locally. You can pop it open. You can use Oumi. You can run Oumi train, specify config, and you're good to go. In this example I have here, maybe you're training a small model like Llama 3.2, 1 billion parameters. Now, if you have a machine that has a few GPUs, you can run distributed training locally, perhaps using Torch Run, or say you have some cloud credits, maybe for GCP or AWS, Azure, Lambda, etc. You can use the Oumi launcher to go ahead and spin up a small cluster on the cloud and run distributed training there. This is the exact same configuration, and now I'm running on 4 nodes in the cloud and running distributed training, not even on my local device. And the last part I want to talk about is actually running at enterprise scale. We've had the opportunity to run Oumi training at scale on a cluster called Polaris, which is from the US Department of Energy. You can see in this specific cluster, we're running on 256 nodes, where each node has 4 A100s. So you can do the math. That's over 1,000 GPUs, and Oumi has worked at that scale. Now, I'll give a more concrete example here, too, of an actual configuration we ran for a slightly smaller model on Polaris, just so you can see what it looks like. When we're running this configuration, in this case, we're going to be tuning Llama 70B SFT, And you can see that we actually can run this config and it works out of the box on Polaris. Here we're using 4 nodes. I mentioned each node has 4 A100s. So this config is using 16 GPUs to quickly train Llama 7DB in this case. But now say I want to reproduce this result outside of Polaris. Well, it's quite easy for us to do. You can just change the cloud name here to AWS or GCP or whatever cloud provider you want, and then just change the setup here. You'll notice there's some PBS directives that were specific to Polaris. You can just replace this with pip install Oumi, and you're good to go on any other cloud provider. So to recap, getting started with Oumi is extremely easy. You can pip install Oumi today. If you have GPUs, pip install our GPU package. Or if you want to use any cloud providers, pip install the appropriate provider for your cloud. We have docs where you can go and take a look, and I highly suggest you to take a look at our docs here. It's oumi.ai/docs, where we have tons of notebooks to help you get started. So you can start using Oumi today locally or on the free notebooks or free collabs that are available from Google. And so going forward, I'm extremely excited for where we're going. We have a very ambitious roadmap, which we'll be sharing shortly, but we're going to be expanding our offerings across models, datasets, benchmarks, and potentially even different modalities. One part I'm specifically interested in that I'm working on myself is custom kernels to actually improve our performance of Oumi across all scales. But as Manos said, to make frontier AI open, we really truly have to work together. So I do want to recall back that democratizing frontier AI is really a team effort. And I'm going to hand it back off to Manos to talk about just that.
Thank you, Matthew.
Yep.
Let's see if you stop presenting. Okay, thank you. I should be able to present again. Okay. So yeah, as Matthew mentioned, we built Oumi to democratize frontier AI research and development. Again, going end to end, the full spectrum from standardize the data so it's easy for you to use, helping you do data synthesis, even with the biggest open LLMs, taking care of all the distributed processing, batch processing, and all of that, helping you curate the data then with LLM judges, all the different pre-training, post-training approaches, evaluation with most of the most common academic benchmarks already integrated, ability to define your own, or again, use also LLM judge against for auto evals. Pretty much, again, all the steps that both researchers in academia were telling us that they need, but also in enterprise. And again, all of that very easy to use. Matthew showed you can go seamlessly from your laptop all the way to any cloud provider you can think of right now, to even a large cluster if you have your own. But yeah, as Matthew was mentioning at the very end, for this to make this work, and as I mentioned at the very beginning of this presentation, we need to work together. That's why from the moment that we started building Oumi, we reached out to quite a few universities that were close to us, and we, in many ways, we're already working with. And quite quickly, that list grew. We're working already with over 20 academics from 13 different institutions. They're very excited about the mission. They're very excited to help. And at the same time, they say, this is a tool that, it also helps us do our own work, because it helps us do our own research, and at the same time, by using this, helping make it better, contributing the research back, because then it's easy for everybody else to produce. We're also contributing to this mission of advancing frontier AI in the open. But even that list that you see, you may say, okay, that's a good list, but even that, it's not good enough. We need all hands on deck. That's why we want to have participation and collaboration, use, improvements, contributions from anybody in the industry. That's why, again, we also build Oumi to be industry grade, so that people in the industry know that they can rely on this. Arguably, this is even good for a researcher, right? You don't want to be using something that's open source, but it's buggy, doesn't work. You want something that you can rely on. But again, this is also very important, because the moment something like that gets used by industry, and then they contribute, they help make it better, we're talking about a vast community of developers and researchers that could be contributing to this. At the same time, also for academia, that's why we also built Oumi to be research first, very easily extensible, because we know academics, they want to push the state of the art. Hopefully, Oumi helps you with 95% of the problem of the research you want to do, but then you can go just innovate on the 5%. You don't need to build the 95% from scratch. You get the 95% out of the box from Oumi, and then you can go innovate and change the 5% where you can do your research. And again, we want to provide as a tool to all academia. This could be tens and tens of thousands of researchers that could be contributing and building this. Again, a community much, much larger than, again, a couple thousand people that you have inside Google DeepMind or inside OpenAI. But even beyond that, going to Greece, I'm sure many of you may feel, okay, we have limited funding or we have limited GPUs. I would say, many people around the world feel the same way. But there's a lot of things that people can do even at small scale to prove that specific recipes work well. That then, we together with collaborators, NVIDIA's, Meta's, can take and scale up. So again, even at Limit Compute, there's a lot of things they can do. Plus, I strongly believe there's exceptional talent in Greece. We're recently also talking with the Archimedes Athena and Archimedes groups. Very excited to also be talking with you today. So yeah, I would strongly encourage you, to help. Hopefully, again, we can help you with your own research, and hopefully, as you do it, you also contribute in making this easier for others to reuse and advance frontier AI. Also, as a quick mention here, as I mentioned at the beginning, for some of the groups that we collaborate with, we may be able to help also with some of the compute needs. And I'm very hopeful that, as we can see, as Matthew said, we've been very motivated and excited to see the adoption and the excitement from the community. Because as we work together, as this community grows, I'm very hopeful that we can go back to Sam Altman and help him correct his statement that actually it's not hopeless to compete with OpenAI. It's actually hopeless to compete with open source AI. So again, to close this off, I'm really hopeful, go give Oumi a try. I'm listing here the GitHub link. Give it a star. Please support us. Join the discussion on Discord. We're already forming different work streams to push the frontier of AI on different areas. We have also some bigger moonshot effort that we're going to be launching soon. So yeah, I really hope that it helps you. I'd love to see you guys in the community. I'd love to collaborate. So please reach out if you're interested. And before we close this off, we have a video that perhaps many of you may not have got a chance to see. So maybe I'll play that. Let's see. Okay.
Throughout history, humanity's greatest achievements have come from open collaboration and the sharing of knowledge. Pushing the boundaries of what's possible has always been a collective effort. We now stand at the cusp of a new era.
Nice to meet you.
Whatever industry you work in, AI will transform it.
AI is increasingly becoming the exclusive property of a powerful few, developed secretly behind closed doors, seeking to dominate by discouraging others.
We're going to steamroll you. It's totally hopeless to compete with us. The abuse of power, it's very frightening.
Why should we trust you?
You should not trust one company and certainly not one person with it.
To be trusted, AI should be advanced,
Collectively?
Transparently.
Responsibly.
open.
Openly.
We believe that the future of AI is open. Join the movement.
Okay, that's it. Yeah, very eager to hear any questions you guys may have.
Thank you, Mano and Matthew. It's an interesting talk in a very interesting research topic, and I also like the video. I have shared this with you, my feedback. So anyone who has question, he can either raise his hand and we unmute him, or put in the chat, whatever you prefer.
Either works for us. I'll take it if there's no questions, that everything was so crystal clear and everybody fully agreed with everything.
Always.
What, can I go?
Yes.
Can you hear me?
Yes,
Hi,
we can. Yeah.
Sorry, I cannot switch on my camera because I'm on the move. Thank you for the very interesting talk. I understand you tried to squeeze a lot of information in a limited time, and I appreciate that. It was really, I think, came across very, very nicely. And thank you for taking this initiative. I have two questions. I will start with the first one. The way I understand it, Oumi is a company.
Mm-hmm.
So what is the business model of the company?
Yeah, great question, Yorgos. Actually, we were asked the same question when we presented this to Oak Ridge National Lab. It's the biggest national lab in the US. And it's okay, we really love what you guys are doing, because even for us, and, they have some access to some of the biggest clusters. We are not sure what our position should be, how we, even as the biggest national lab with all these biggest super clusters, how we can contribute, because we feel that, OpenAI, Anthropic, they're just going to dominate. So, and I'll answer your question also, Yorgos. And what we told them is that, you know what, we can solve this problem. You can solve this problem on your own. We need to work together as a community. And what we're trying to do as a company is the same model that we had inside Google for Palm or Gemini, where we had the common platform that enables everybody to advance frontier AI. We established the same platform, and we help the community to advance that research. And now go to the business model. Our business model is that what we call the Linux of AI, which is the fully open source platform, and anything that it takes to develop the generic foundation models should be fully open, no paywalls, no friction. Again, the same analogy with Linux, so that we can all work as a community to advance frontier AI together. Not just Oumi, not just that specific national lab in the US, not just any single entity, but the same way happens with Linux, as a community together, as a public resource. That's why everything that we have on the GitHub that I'm saying here is Apache 2, right? You can take it, use it however you want. You don't have to pay us or anybody else anything. It's fully for your benefit so that the whole community can benefit. Now, as a company where what is called a public benefit corporation is still a for-profit, but because we have this very strong public benefit mission, that's why we decided to incorporate as us. And there's some requirements about how reporting biannually, how we're advancing and helping humanity, towards the mission that we have. But anyway, to be a little bit more precise, our view is that we want there to be a very strong Linux of AI, right? Because it's good for the sciences, for the industry, for humanity, for everybody. And then as more and more people use that Linux of AI, especially enterprises, not academics, because we want everything that researchers and academics need to be freely available, but especially as enterprise go to production, they may say, you know what, okay, I can now use these generic foundation models to develop my own commercial, closed source, whatever, private model. But at the same time, I may need some support to make sure that my models don't hallucinate, or I can monitor how well they work in production, or which actually these are solutions that we can provide to them for a payment. For example, they may say, you know what, I want to use the platform, but now I want to scale up and use more compute that I don't have in my own cluster or in my own resources. Can I use Oumi as a service? So that's kind of the model that we're going after. Again, mostly for enterprises, because we want for anything that helps the open community, for that to be freely available. So again, the community is uninhibited to make the best AI for all of us. Because if the open source AI is not competitive, then everybody's going to go to Google Cloud and use Gemini or Azure and use OpenAI, which is what we don't want to happen, not just for the sake of this specific company, but for the sake of all of us. So, Yorgo, hopefully that suffices.
Yeah, sorry, it's windy here. It was very good, thank you. Although I'm not very familiar with the business model of Linux either, but
I would say the summary I tell people is that we want to help to give it a quick analogy. We want to help the community build the best Linux together, and then we can monetize as the Red Hat. That's perhaps a quick way usually we put it. But for that to work well, there needs to be a strong Linux. Otherwise, it won't go anywhere. So you could say, provide services to companies if they want help to develop their own proprietary models, the extra compute they need, or extra systems to put those things reliably in production. That's kind of like the short summary.
Okay, and if I understand correctly, companies, commercial users can produce their own closed source software based on the open source projects.
Exactly. They can take Oumi, deploy it on their own infrastructure, training with their own models, as for example we will do as well. Our thesis, just to be very clear, is that the generic foundation models, because people use them for climate science, material science, people use Llama, even the text model, and we're discussing about using the vision ones as well, as the baseline, as the foundation to start doing partial differential equation solving, healthcare. That's why we say, because they're so generic, we should democratize the access to this. And then any organization, ourselves or any other enterprise, can go on top of that and develop proprietary closed source models and solutions. But the core foundation, because it's so generic for many sciences and all of that, it should be more accessible and can be better advanced by an open community.
Sorry, maybe I'm monopolizing. Foti, interrupt me if people want to ask questions. I cannot see the hands. So that does.
George, you just muted. It's Alexandros also pending, but you can ask one more question, I guess. Yeah. You're not muted, though.
Okay, sorry. So what I wanted to ask is if somebody contributes to the open, so you're asking people to contribute to this open source effort. If somebody contributes, is this contribution also going to be used for commercial purposes, or can they select their own licensing, if you will?
You could select theoretically your own. That being said, our preference is that anything that gets contributed in the other repository, it's Apache 2, and hopefully it stays Apache 2, which is very permissive. Apache 2 says any researcher enterprise can take it and use it as they see fit. So that's why our preference is that any such research contributions, they stay Apache 2 or as permissive as possible. Now, if somebody wants to contribute something that is less permissive, we can discuss about it. But yeah, we have a strong preference for contributions to be fully permissive so that anybody in academia or industry can use them freely.
Okay, thank you. I will stop at this point and come back later.
But of course, just at the one last point, like any lab or any enterprise can take this repository, do use it for their own research. Say, you know what, some of these things are proprietary, I want to keep to myself, but some of these are useful for the general public, so I want to contribute them back, right? And they can pick and choose what they decide to contribute. But yeah, anything that gets contributed, we want for the benefit of the whole community to be as permissively provided as possible. Okay, I think next one was Alexandros, maybe?
Yeah, Alexandros, you want to unmute?
Yes. Shall I open the camera? I cannot open the camera, so I'll simply raise the question without opening the camera. So thank you very much for this enlightening talk. I would like, my background is legal, so I will be the bad guy for this, for the sake of the discussion here, legal and ethics. So of course we know that regulation does not apply that much to open source AI. However, if a model is integrated to an AI system for commercial users, or if it is used for a system in high-risk application, or if it is used as a general purpose AI model, then some regulatory requirements actually apply. So I was wondering, what's your approach towards the AI Act requirements in particular, but also how do you plan to align for projects that apply across jurisdictions?
Yeah, okay, let me take the first part. First of all, let me know, Alexander, if I don't fully answer the question. I'll try do my best. So, but the first one is, let's say, as you mentioned, the moment you go to commercial use, there's different requirements. And to give you an idea, I was mentioning before to the question from George, that we want things to be as permissively licensed as possible so that people both in academia and enterprise, for commercial purposes can use them. That being said, to give you as an example, we are going to be releasing a model next week where we say, you know what, because the data that we use to train this model does not allow us to release it as Apache 2, unfortunately, it needs to be released with a different license, which is non-commercial. That being said, we're still releasing it because we think it's beneficial, at least for the research community and everybody else, to have access to this research. So yeah, it may be the case, again, even for us researchers as they do different types of research, that because of the data that they used, or different constraints or models that they use to synthesize data, that the research they produce may not be fully permissive. That's unfortunate. That's why we recommend people, wherever you have options and they're almost equally good, but one is more permissive than the other, try to go for the more permissive, because then you enable anybody in academia and industry. But yeah, if there is no option, then yeah, some things may have to be less permissive, which means you can still help advance the research, but it may not be, unfortunately, directly usable by enterprise. Did I cover that, Alexandros, or maybe not fully?
I think we should have a talk face to face on
Okay.
that. But yes,
More
yes,
than
yes,
happy to have a follow-up. Yeah.
covered a lot, but you gave me also the opportunity to reflect on a different aspect, which is licensing, but not from the copyright perspective, rather the so-called responsible AI licensing. I don't know if you are familiar with this kind of schemes, licensing schemes. So I was wondering whether you have thought of actually applying on this kind of responsible AI licensing, which to my understanding and view in particular, I think is one of the most solid ways to actually, how can I say, demonstrate, showcase responsibility downstream.
Yeah. I think the responsible AI licensing is a very interesting point. And again, correct me if I'm wrong here, but my understanding is that as long as you don't use the AI in any of these, bad ways, then you're okay to use it for commercial.
More or less, yes.
Yeah.
That's the logic.
I think that's a very, very, I think that's, I don't know if to say table stakes, but yeah, this is a very good recommendation or way to encourage people that they use these things, in a good way. Now, somebody could start saying, okay, you put that license, but if it's open, anybody can download the model, do all sorts of bad things, which, opens up to a different type of discussion. Which is, I think, yeah, we should definitely encourage with license or any other ways the responsible use. But at the same time, kind of to preempt, I don't know, a question that may come around this is that we think that the most responsible way to advance this technology is to do it openly, because as I mentioned before, the current closed source organizations, they are cutting corners to try to go towards the monetary goals that they have. And there's a huge community that is interested in advancing the safety of the systems, especially if you make it easier for them. And that's why I think, we can have the responsible AI licenses. I think this is really good to have. But at the same time is that we need to make it easy for the community. And again, we try to make that also with Oumi, to make it possible for them to do all the work that they're interested in doing to advance the safety of all the systems. So even if there's some bad players in the ecosystem, we still build as a community the guardrails, the ability to detect all the deepfakes, all these different things to ensure and help, protect from the bad players in the ecosystem. And I think this can be better done not by obscurity, by having AI be a black box, but by opening it up to all the community, because there's many more good players than the bad players.
Okay, fair enough. I hope I can reach you by next week if it's possible. I'd love to have a talk.
Absolutely. Yeah. Anyone, please, if you're interested.
Okay, thank you.
Yeah.
I see no more raised hands, or I just saw a question in the chat. So it's from Petros Mitseas. Thank you for the very informative presentation. We see a lot of repos and frameworks rising lately regarding building AI agents. There is much research in that direction on how to incorporate memory planning, etc., that work on top of LLMs. I'd like to ask you if Oumi is mostly oriented to building foundational models, or you plan to have to expand the agent building direction with ready-to-use recipes like you do with training models?
Yeah, great question. This has definitely come up before. I would say overall, we would be interested. It's not one of the immediate goals because agents can be very powerful. First of all, if somebody is interested in collaborating and making this happen, please reach out. We can definitely, we're very happy to work together to make this happen. It's just from the resource that we have very immediately, it won't be one of the immediate goals. And the reason is that even when someone talks about agents and automating different scenarios, quite often when we talk to, again, many people in enterprise or beyond academia, quite often it's like one agent that may do a lot of the heavy lifting, the automation, extracting information from a multimodal document or whatever that is. And it's usually that agent that you can extract a lot more value if you go and improve it and develop your own custom model. So anyway, that's the reason why we said, you know what, we really need to help both academia and enterprises with the basic blocks, because they're struggling with the basic components before you go and you add the extra levels of complexity and memory and all these agentic scenarios. So again, we're very interested. We just don't have the capacity to go to them right now. But if somebody's interested in collaborating to make this happen, I would love to discuss with you. But yeah, for now, the goal is to help academia, at least the immediate goal, with the core research itself of advancing foundation models or adapting them to different domains and tasks.
Okay, thank you very much.
Are there any other questions? George again. Yes, George.
If there isn't anybody else, I will go. Related to the previous question that was asked, there are several other efforts like Hugging Face who seem to be targeting democratization, and you mentioned both of them, democratization and Hugging Face, in your presentation. What is the relationship? Why did you feel the need to start something new instead of building something on top of an existing effort?
Great question. So actually, we're building on top of Hugging Face. Also, Clem DeLang, the CEO of Hugging Face, is also one of our angel investors. So we're building on top of Hugging Face, but same going beyond that. So what we were hearing, both from academics, some of the, most well-known universities in the US, many of the, 20 academics, pretty much unanimously from all of them, was that it's very hard for students to do this type of research. Yeah, there's Hugging Face. But even to be able to do this type of research, you need to put, I don't know how many different repositories, even just for evaluation, how many, perhaps a dozen repositories you may need to use across Hugging Face, depends on how broad you want to go. And it would take a lot of effort for them to figure out what are all the different things they need to put together to do this type of research across the training, the evaluation, if especially we want to do data synthesis. Anyway, so they said, that's kind of hard. And the way usually I put it is that Hugging Face is more of a warehouse of components. We're building and reusing Hugging Face in many ways, wherever we can. But the goal with Oumi was to make this more of a factory of a workflow for AI development and research, where you have all the things that you need behind a unified API, all the different models behind a unified API. You can easily experiment from one to the next. Again, all the evaluations that you need without having to clone or, pip install. Literally, it could be a dozen repositories, depending if you want to evaluate thoroughly a new model you're building. But at the same time, also go beyond it. For example, for training, we support the TRL training library from Hugging Face because it's quite commonly used. At the same time, many people say, actually, it's not the best training library. It's not the most efficient. We're not getting arguably the best results. And that's why right now also we're integrating Torsion. Then if you go to RL, it's even more chaotic, the field of trying with different RL libraries. And what we're doing, you can come with a unified API. You can move from TRL to Torsion to any of the other library, or you can test both open, and we forgot to mention this perhaps, even closed models and readily compare all of them. So you can easily, compare all the different tools and also move across the workflow from, again, the data synthesis to the curation, to the training, to the evaluation, without having to rebuild all these things together. Another way to put it actually, perhaps that may help, is that imagine you're doing research on Linux, that I used this analogy before. Currently, it feels that somebody will have to say, okay, let's say I'm a researcher that does research on memory management subsystems, right? I'm a better paging system for Linux. I'm going to have to go figure out what is the page management system, what scheduler, what device drivers, what UI subsystem, what this, what that, put it all together, so then I can go do my research on this specific narrow area. That's almost where we are now with AI. And plus, when people put together, often things don't work. Again, I don't know what your experience has been, but at least we're hearing from 9 out of 10 students that said, we weren't able to distribute the training. We didn't even get there because even just putting everything else together took us so much effort and time that we just didn't have the capacity or the time to do this. We just had to move to the next research effort.
Thank you again. Fotis, if somebody else wants to, somebody else?
Yeah, and actually, maybe to ask a very good point on this, George, is that we definitely didn't want to reinvent the wheel where we don't have to. That's why, again, we're building, help make it even more accessible for people to use the most common Hugging Face components, but also going beyond them and testing other things as well. Okay.
I don't see any other question. George, if you wanna ask something more.
Yeah, I have a couple more. I always do. Sorry about that. So you mentioned the platform. I was under the impression, perhaps it was a false impression, that you're also providing a new LLM. Is this the case, or have I just misunderstood?
Yeah. So the short answer is, well, not right now, but yes. Or at least not, okay, partially. So we have some research efforts that are already in progress. One of them, we already published the paper on Archive maybe about 3 weeks ago. It's an agentic model that on function calling tool use, it beats GPT-4o in many benchmarks across the Berkeley function calling leaderboard. It beats Claude, Gemini, Mistral Large. And we published that paper. Actually, if you go to Oumi, there's a page. I don't know, Matthew, if you can find it, quickly share the link maybe in chat here. And you can see the researchers put the whole page. They say, you know what, okay, you can reproduce our work. 2 people install Oumi train with a specific recipe, and you can train the 8B, the 70B, or even the 405B, assuming you have enough GPUs available. So anyway, we're doing this type of research where, yes, you could say we're taking existing open models and making them even better, and then contributing those recipes in a way that is very easy. Again, literally with 2 commands, you can reproduce it and then go off and make it better. That being said, while we have some such small focused efforts, we had over 100 people that reached out and signed up a form when we launched and later that said, I want to help with these research efforts. And now we're organizing more and more such focused research efforts. And we have also what we call a moonshot effort that we're going to be launching in a couple of weeks. We've been a little bit heads down. We've been trying to get to it. And Matthew keeps reminding me that I need to continue making progress on it. But anyway, the idea for that is to work with the community to develop a better instruct model across the board, which means that we have the platform, we have the ways that make it easy for people to do this research, but hopefully at least even with the limited compute that they have, they can prove on the benchmarks that we define ourselves. We're also collaborating with ML Commons to help them with defining those benchmarks and build more in the future to improve. And so, you know what, okay, I did this research, I improved the quality on this specific benchmark without regressing on all the other ones. And then again, work together as a community to improve overall the quality and develop the best, let's say the next DeepSeek can be on the next open model that is better than what's out there while contributing all the open recipes. And the goal is that if people prove on the small scale that, hey, I managed to improve without regressing, then we're going to take all these improvements because they're going to be on the same platform, evaluate across the same axes, the same benchmarks, and combine them to train a bigger model. And then we're going to co-publish a paper with everybody that contributed, everybody who contributed with in data sets, the training itself, in whatever way, and share the results as a community effort. To give you an idea, this is the same thing as how I had organized the efforts for Palm, or when DeepMind took over, how they organized the efforts. We say, everybody has the same training infrastructure, right? And that's what actually we're trying to give the community, the same superpower, the same tools that we had inside Google, to give them the community as easy it is for people inside Google to use, also to provide tools that are as easy for everybody else in the community. We define the benchmarks. People prove at a small scale they can improve the state of the art. And then we take all these small contributions, we combine them, we push a red button, and we train a bigger model that we then share with everybody. So that's the plan. Again, it's almost expanding and slightly adapting how even these big foundation model companies work internally. And, as I mentioned before, I think can be better done within the community because there's so many sub-problems across many modalities that researchers can tackle in parallel and prove at small scale that they can improve state of the art. And then again, somebody can push the red button and train the bigger one. So yeah, we're going to be announcing in a couple of weeks. Please don't spill the beans. Yeah, it's going to be coming out soon.
And sorry, one last question from me, and I may lose the network in a bit. You mentioned the AI factory Pharos that is starting in Democritos and in Greece in general. Have you discussed with the team in the Pharos team in Democritos how you could work together, or whether because in Democritos you have?
No, I was going to sorry for interrupting. I thought you were done. I was going to say no, I haven't, but I would love to discuss with them.
Yeah. So just to give one in one line, what we will be doing in Democritos will be the platform, not the hardware, but the platform. So I think it is a very good idea to have a discussion.
That's great. Yeah.
And
Yeah,
sorry, I
very,
will
very
need to leave. Thank you very much. Thanks very much for the discussion. And I hope that we will have, again, a more specific discussion about the collaboration on the basis of the fact.
Absolutely looking forward to it. Yeah.
Thank you. Bye-bye.
Bye, George. We're a bit past our time, but I guess we would have one more question if there is anything else to ask. If not, I want to thank a lot Manos and Matthew for the presentation and the interesting discussion. Of course, everybody who wants to ask something or share ideas, we can take this offline and send to the guys. I think they're very interested in feedback right now. Yeah, and thank you all for participating. Yeah. Thank you,
Absolutely.
guys.
You know, that's our email address for me and Matthew. Maybe we had it also on the slides. Yeah, feel free, please reach out.
I think it's in the invitation as well, but
That's
yeah,
great.
in any case, yeah, it's good to share in the chat as well. Okay.
Awesome. Yeah. Thank you, folks.
Yeah, thanks everyone.
Thank you.
Thank you,
very
guys.
much.